Hey there, this is Penelope. This is a video on integrating quotients. And in these examples, the expression to be integrated will be a quotient where the numerator is either exactly or a multiple of the derivative of the denominator. And if the numerator is either exactly or a multiple of the derivative, then the integral will basically be the natural log of the denominator. So we could finish this formula here and say that it's equal to natural log of the denominator. So have a look at this. Does it work? Yes, it does. The numerator is exactly the derivative of the bottom line. So just as a check, let's try differentiating the natural log of x squared plus 2. Okay, so the derivative, this is just a check. We're checking to see whether this is the correct thing to do. Okay, the derivative of a log function is the derivative of the bracket times 1 over the bracket, which it is. So that's what we needed to integrate, so then we can go straight to saying that the integral of 2x over x squared plus 2 is natural log of x squared plus 2. So this is where the top line is the derivative or a multiplication, a multiple of the derivative of the bottom line. So we could just use the formula without actually trying to check it out first. So have a look at this one now. This one is not quite so straightforward. It is something to do with the derivative of that, but let's try and see if it works. Try differentiating the natural log of the bottom line, and we see that we get the derivative of the bracket, which is 8x times 1 over the bracket. That's 8 times too big. So let's just say that the integral of x over 4x squared minus 1 is 1 over 8 times the natural log of look at this one. This one is kind of right, kind of not right. Again, we might check it out first. Well, let's do it. Let's find the derivative of the bottom line and see what's wrong. Okay, the derivative of that is 6x squared plus 8x minus 2. This is a factor of 2 times too big. So all we need to do then is say the integral of 3x squared plus 4x minus 1 over 2x cubed plus 4x squared minus 2x. Okay, it's 2 times too big, so we divide it by 2. Oops. And we're done. Now let's see if I can put in a new slide. Okay, it's not going to be a very nice slide, but never mind. Okay. Now I've got rid of all the rubbish, now it's much neater. Now, same thing where we've got the derivative on the top and the function on the bottom. Let's look at something like finding the integral of tan x. Now you can look it up on the table, but let's see how it works. Let's remember that tan of x is actually equal to sine of x over cosine of x. So the integral of tan x is the integral of sine x over cos x. Checking this out, the numerator is more or less the denominator of the derivative. Let's try it. Let's find the derivative of the bottom line. And we see that it's negative sine x. Okay, so we're only out by a factor of -1. So the integral of tan x is going to be negative natural log of cos x. And that's what it shows in your table. Similarly, the integral of cotangent of x is the same as the integral of cosine x over sine x. And checking that out, the derivative of the numerator is exactly the derivative of the bottom. So we're fine to go and say that the integral of cot x is equal to, straight away, natural log of the denominator.